Okay, thanks, folks. So my name is Rohit. I'm a software engineer at Meta slash Facebook, and I mainly focus on the latency-sensitive queries in Presto. And today I'll be talking about materialized views in the Presto. Okay, so let's start with materialized view. What is materialized view? Materialized views is pretty popular technique to solve problems such as when you got like complex queries, processing lots of data, and specifically doing like the aggregation on top of joins or plain skeins and some other complexities. Such queries can be really expensive and compute heavy. And materialized view is a great technique to solve and reduce latencies of such queries by reducing the cardinality and scanning only pre-computed and persisted data. Materialized view in essence is just like regular views, but pre-computed and persisted as well. So when you are reading from the materialized view instead of regular tables, you are looking into the results which are already pre-computed, hence achieving very fast results. So materialized view is a really great fit for queries that are repeatable and compute heavy, specifically aggregation heavies. Materialized view is also pretty popular in the data infrastructure technologies such as Google BigQueries, and it is already supported there, like in Microsoft and Amazon Redshift, Snowflake, etc., pretty much everywhere. And it has been missing in Facebook for now. And we were wondering why, because Facebook also has lots of other great data infrastructure related technologies and framework, and hence in order to figure it out, like is it really required by metadata engineers, and we did like the survey, and not surprisingly it came out as a top ask in the customer surveys at Meta. Around 60% people asked for materialized views and its general features for simplifying pipeline acceleration and making queries and compute efficient. There are essentially two themes came out of it. The first one was the users mentioned that they wanted to focus only in the business logic. They don't want to go into the business of managing these pipelines where they have to worry about optimizing these pipelines. They have to worry about the scheduling of those, whether they're running, not running, my data is coming well or not. Because most of these data users, predominantly use case has been dashboards, where users are taking a bunch of these tables, joining them, doing some aggregations, and coming up with these nice reports. So these dashboards are backed by some table, which is an aggregation of some other tables and things like that. So then these users need to worry about these pipelines where, okay, if their data is aggregated on the fresh data, because the base table is changing constantly, right? And things like that. So those are the two predominant themes came out of this survey, and those are the things which we kept in our mind when we designed materialized views in the Meta for Presto. So as I mentioned, a lot of data infrastructure companies have supported materialized views, and there are different nuances of those are there in different companies. So we extensively researched and debated on various key. So the first one is fast, as I already talked about, because they are pre-computed and persisted views. So they are fast because you're essentially working with a lot less cardinality, and you're also working with the data which is already aggregated. Another one is always consistent. As I mentioned, like the materialized views are basically like another storage which is pre-aggregated, and the actual source of data is sitting in its base table. So which means the materialized view needs to be regularly materialized, because the base table might be getting new partitions. So every time the base table gets the partition, you need to move that new partitions into the materialized view. So at any state, the materialized view may have all the data which is present in the base table. It may have some data, or it may not have any data, especially if you just created the materialized view, it may not have any data. So in a regular scenario, if you are going to read from the materialized view and it is only partially materialized, you're only getting to get partial data, and that is which is not consistent if you read from the base table, because you're going to get something else from the base table and you get something else from the materialized view. This was a very important property for us, and we decided to implement materialized views as consistent. What it means is that in any state of materialized view, in any state of its materialization, if you read from the materialized view, you will always get the complete picture of the data. You will get consistent data. How we have done it, I'll talk about it a bit later. Another feature was automatic rewrite, so which means if you have created the materialized view for a query shape which was quite repeatable, if you use those queries, we will automatically leverage materialized views for such queries. So it means user does not have to worry about changing their queries to gain materialized views access. We'll cover this more later as well. Last, no maintenance. So which means the engine keeps materialized view up to date automatically. Means like as the base table is getting new partitions and new data, there are jobs running in the background automatically, which keeps ingesting new data into the materialized view. This particular feature is only built in the Meta infrastructure. It is not available in the open source at this point. Rest all whatever I have talked and I will talk about is available in the open source feature. This is like the first time we are talking about materialized views in the outside communities. Next. Okay, so how can user create the materialized view? So materialized view functionality is, one second, I'm getting. Yeah, so materialized view functionality is supported by the Presto SQL, and the user can create materialized view just like regular views. As you can see in the syntax, it sounds pretty familiar. Create materialized views, and the second part of it is you provide like the partition information, then you provide the repeated query pattern for which the materialized view needs to be created. The moment you fire this command, the metadata required for the materialized view is stored in the high meta store, which later can be used to provide consistent results and to provide fresh materialized views. In the meta infrastructure, the pipelines to provide to keep ingesting the materialized views also get created along with this. The next is refresh SQL. So the materialized view, as I mentioned, like they can be like regular tables. So anyone can potentially insert the materialized view and can disrupt the harmony between base tables and the materialized view. Hence, to avoid that, directly inserting to the materialized view is not allowed. Instead of that, a refresh materialized view command is provided. User can use this refresh materialized view command to ingest new partitions into the materialized view. The command is pretty simple. It takes a partition information or a list of partition information for which this materialized view needs to be refreshed. Moving on, query 6. How can you query the materialized view? So materialized view can be queried just like any other table or logical views. So you can just fire your query, like select blah, blah, whatever aggregations and things like that you want to do from materialized view. Or the Presto can automatically rewrite queries to leverage materialized view. If Presto finds out that a particular query shape is backed by materialized view, then it will automatically leverage the materialized view to speed up that query performance. This particular feature is really powerful because user does not have to change their original queries, which can itself be a quite cumbersome job because because these queries may be generated by some tool or program and things like that. Okay, here is a simple example how does automatic query rewrite works. So let's say your MV materialized view definition is this definition is not complete. This only talks about the repeatable query pattern. So select A, which is alias to MVA, and from the base table, if the user is doing the base query aggregation as sum of A, from the base table. If this particular query is fired and the Presto recognized that the first line as materialized view is already present in the system, it will rewrite this query to select sum of A instead of sum of MVA, MVB from MB. So user did not need to do any work, and this query already started reading from the materialized view to gain benefits. Here is another example. It is pretty similar, but in this particular case, if you see like the MV definition of sum of discount into extended price, as it's basically combining two columns into one single columns in the materialized view. So if user fires a query of sum of discount into extended price, this query will be rewritten to replace two columns into the column which was represented by this. The optimized query will end up reading sum of discount multi-extended price, hence getting the benefits from the query optimization. Okay, let's talk about the always consistent property. So we talked about that materialized view could be in any state, but if you read from the materialized view, you would always read all the data. So how do we do it? So we leverage something called partition stitching to read the delta from the base table. So anytime a query is fired for the materialized view, we go to the respective base tables and see, hey, what are the new partitions are present in the base table which are not materialized yet. After we get those, if you fire a query against table T, if the automatic query rewrite is enabled, this query will be converted to read it from the materialized view. So query T becomes query MV, and then the query MV becomes query MV, basically reading all the materialized data, and it is doing the union of Q delta from the table. So delta is basically the missing data from the materialized view. So it reads all the materialized data, and it also reads the non-materialized data from the base tables. This particular feature is not present in and other places in the materialized view, but the consistency was fairly important for us as a Presto community, and we ended up providing the supported. For most of the use cases, this complexity, not for the most, but many use cases, this complexity may not be required, and user might be happy and satisfied reading only the materialized data from the MV. And we have this configuration where user can disable this and read only from the materialized data if they like. Here is an example of partition stitching. So let's see an example MV is created while doing the sum of total. And this base table is pretty simple. ID, which is a partition column, the total, which is another field. If you end up doing in this state where example MV has only partition ID equal to 1, the partition ID equal to 2 is not materialized at this point. So if you read from the sum total example V, and if you read only the materialized view, you will only see 10, you would miss the 20. So this particular query gets translated into some kind of this form. This is a simplified form. It's not a complete form. A lot more other things are generated to take care of many other things. But this covers the essence of the idea we want to talk about. So this particular query select sum total from example MV gets converted to select sum total from example MV union all sum total from example T, where ID equal to 2. So ID equal to 2 is the only thing which is read from the base tables. Moving along, partition mapping. So how do we recognize the delta? So which is a fairly fundamental component for which is the partition mapping. So anytime you create the materialized view, you do need to provide the partitions for which this materialized view needs to be created. And the partition has this condition that at least one partition of every base table must be present in the materialized view partition. So which means every partition in the materialized view must have the witness witnessing the base tables partition. So which means like one-to-one mapping. The partition name can have aliases. They don't have to be strictly same, but the partition values must be same because those are the values are used to determine which partitions are present in the base tables or materialized view or not. So they cannot have any transformation to change the semantics of it. All right, what exactly we support from the materialized view perspective? So the single table, we support pretty much everything. We support like with, group by, having, order by. We support pretty much all the aggregation functions. In the aggregation functions, the automatic query optimization has limited support. It does not work for all of them. We can, in terms of join, we only support two table join, and we only support inner join and the cross join, cross join and nested. We also support union, intersect, excepts. We support all kind of subqueries, so you can create nested queries, pretty big queries, things like that. Subqueries inside the from are supported. So our support for materialized views are pretty rich at this point. The automatic query optimization support for query shape is limited than the materialized view support itself. We do not support join on multiple tables at this point, more than one table, more than two tables. We do not support left, right, full outer join at this point. Subqueries inside the where clause as well are not supported. And we are constantly working to increase our support for more query shapes and things like that. So this will change. Okay, wanted to talk a little bit more about no maintenance mode, which is available only in the Meta infrastructure at this point. So what it is, we have like automatic scheduling, as we talked about, to ingest the materialized view to keep up to date with base table regular changes. The typical the infrastructure for this looks like this. In this slide, we have lots of face meta components, but it is fairly straightforward. So as you create the materialized view in the Presto, we store all these information in the Hive meta store. And this Hive meta store sends a signal to warm scroll subscriber. So warm scroll subscriber is basically nothing but a pub sub component in the meta infrastructure, which takes these events and sends all this to Kronos. Kronos is basically like a scheduler component. And what it does is basically it creates schedules jobs for the materialized view back to Presto. So we did talk about like the refresh command. So Kronos at this point, all it does is basically keep sending refresh commands to back to the Presto. And specifically, if you look into the blue events, basically any CRUD events happening on the base table partitions, which means new partitions are being created or deleted and things like that, respectively. The PubSub model, with the help of scheduling component, schedule respective refresh or delete partition jobs from the materialized view to keep it up to date with the base table. All right. So what are the benefits for the Meta consumer? I think like some of these things we talked about. A lot of the consumers who have used the materialized view, which is available at this point in the beta. Basically, it reduced their barrier to entry because they only focus on their business logic. It democratized their data by providing lineage information, and they have a lot of visibilities how these dashboards with the help of materialized views are created. Their queries are being accelerated transparently, and not but the least, it provides insight faster. Okay, so at this point, like the another cool feature which we are working inside Meta for Presto is to look into the query logs or the query traffic, live query traffic, analyze that, and create these materialized views automatically. Right now, the support for materialized view is provided by creating these materialized views manually, and users are using like that. But we are also working on where we are getting lots of query traffic in the Meta infrastructure for Presto. What we want to do is like we want to look into the query traffic and predict what all the materialized views would be helpful to increase the query latencies or increase the efficiencies of the system. And we want to create those materialized views automatically to improve the overall performance. And eventually we want to move towards like machine learning to predict and create these materialized views intelligently and monitor those. And depending on the hit rate of materialized views, uh, we want to maintain those, not just creating those, but drop the materialized views which are not turning out to be helpful. Going back to our roadmap charts, so we started working on materialized views sometime this year, and we ended up doing like the successful prototype while creating the materialized view. We ended up adding the validation and refresh stuff. We ended up adding like automatic query rewrites. We ended up adding support for other frameworks. The stuff which is working on right now is basically like we are reaching out to more and more customers, trying out and see how their stuff gets improved in the real time. We are also working on automatically creating the materialized views given query logs or query traffic. And last but not the least, we are working towards general availabilities. At this point, it is available in the beta, and we need to work a lot on the monitoring and operational aspects of it to make it general available. And finally, we have come along we have come we have come very far to build great features. Thousand lines of code has been checked into the Presto to build these great features, but there's still a lot of a lot of things which are missing, and we are looking to collaborate with all of you to keep moving in the right direction. So one of the places where we would like to collaborate is building this no maintenance component for the open source. We want to play with various ML models to help us create different materialized views automatically depending on various metrics. We need help with the more query shape support. There are very challenging NP hard problem for filter containment problem. And try it out and let us know how it helps, doesn't help, what's missing, what's working, and things like that. There were a lot of other things which I wanted to cover in the thing, which are very fairly complex regarding like the partition modeling. If the materialized view has less number of partitions, more partitions than the base table, the privacy related support, the lineage related support we have added. In the interest of time and keep it simple, I have not covered those, but if anybody is interested, we can always have a sync up offline or chat on the Slack and help you provide all the information you need. Thank you.
Awesome, great. It takes me a second to get in here. So for starters, you mentioned Slack. So again, a reminder to head on over to Presto Slack in case you have questions, but we also do have some questions for you right now. Let's start at the top. Our materialized view incrementally refreshed fast or recreated entirely slow? How do you handle deletes and updates of data at the source?
Great question. So when I think like some of the things I did not cover is like the partition matching. So if the partitions are matching like 1-to-1, like let's assume like your base table has DS, basically like day and hours partitions, and the materialized view has only, if it has days and similar partitions like days and hours, then it is refresh fast. Basically like the new data comes, you just do not touch the other data, you just process the new partitions and update that. But in certain cases, let's assume the materialized view has only day, does not have hours. So any new hour data in the base table would impact the materialized view entirely. So which means you have to delete the day partition and then build the day partition again. So in that case, you can think it's recreated. I'm like, it's not like the entire materialized view is created, but certain partitions would be impacted completely. So you have to delete the partition, then update, rather than incrementally keep adding new data. How do we handle deletes? Deletes are similar. So if the partition is deleted from the base table, we have all these PubSub model and gets respective events, and we end up deleting those information from materialized view as well. So the materialized view, the metadata gets updated immediately. So the user does not read those partitions, but eventually it does get deleted from the meta store as well. Sorry, the materialized view itself as well. Does that answer your question?
Well, Hamid, please let us know if that does or doesn't answer it. And moving on, then we'll ask Jim Apple is asking, can you discuss the rewrites that Presto can't automatically do, or is it guaranteed to always find potential rewrites?
So what I understand from this is, so if the rewrites, the automatically rewrite or the query optimization, if Presto cannot find a good materialized view which can handle the given query shape, if it finds a good materialized view, it will switch the query shape to leverage that particular materialized view. It may be possible that you find more than one. So then it will try to take the best one. I don't think like we have built that right now. It takes just the first one, but we plan to build the logic where it takes like which is the most efficient materialized view available for this particular query shape. If it does not find, then it will just use the actual query, which user fired uh, to compute. So in that case, like no optimization would be available.
Okay, cool. Moving on. Are these already part of the open source, or is this all open source already?
Oh yes, so it's already open source, have been part of open source for a while. We have intentionally do not put any release notes for these materialized views because we wanted to be sure, because this is a big feature, we wanted to make sure it works end to end and it is stable before we announce to the community. So we have intentionally have not put these as part of any release notes, but except like the no maintenance and automatic scheduling part, all the features are available in the open source world.
Cool.
Soon we will have a document describing all the features and configurations, because there are tons of configurations available tuning different features and aspect of it.
Spectacular. And then how do you handle the atomicity, which is a great word, required when checking the partition delta concurrently with adding new partitions?
So when the new partitions are added, it will, I'm not sure if I understand the question completely. Maybe
Jim,
I can talk to Jim later.
Yeah, okay.
So I mean, like, but whatever I understand, so I think like it's a fairly concurrency problems, like something which we have worked with our Metastore teams in a great deal. So we want to make sure as anytime like the new partition is added, we want to make sure like it gets added into the Metastore immediately. See, if it is produced in the materialized view or not, it is irrelevant, because when we are processing the query, we will learn that what is available in the base tables. So if it is available in the base table, we will end up computing that as delta because it is not present in the materialized. Maybe I'll talk to Jim later and see if this question was answered.
Hamid has another one. I assume you handle the race concurrency between materialized view refresher and the query. While the query is being executed, materialized view may be refreshed. You have many queries running, so you can't quiesce the materialized view. That doesn't seem like a question, so I'm not really entirely sure.
Yeah, I mean, like, but I'm not sure what exactly is the question, but yes, we do take care those things into account. It has been like a part of great debates in our design. Okay. Maybe we'll publish the designs and that will talk a lot more about this in the detail.
And I think our timing is going to be perfect because we have two more. One is from Gurmeet. Thank you so much, Gurmeet. Does the partition stitching only work for new additional partitions in the base table, or also for mutated partitions in the base table?
So mutated means like the partition is altered, or sorry?
Yeah, I would think mutated. I mean, the word mutate. Yeah, so we could assume so.
So if the partition is altered, I mean, like it's simple. Like the alter partition is nothing but like the delete and add new partitions. So if the so it's basically like it consider like the deleted and then there is a new partition. So from the MV perspective, the partition which was earlier populated is a stale partition. We have like this terminology we call like the stale partition. So anytime the partition in the materialized view can get stale for multiple reasons. If it is deleted or updated or altered, as we talked about. And if it is stale, we don't take that into the account. We rely on the base tables as a delta to fetch that particular partition.
Very cool. Okay, and the last question, thank you, Gurmeet, is from Ruben Soto, and I think he's trying to ping me because he knows that I'm getting ready to engage with the community to help inspire you all to write blogs about Presto. But his question is, do you plan to write some blogs to help the first usage?
Oh yes, we do. We want to write lots of blog, and this is something was told to us many times, but yeah, we do want to. We'll prioritize it, and we'll get back to all sort of blocks, like the design blocks, technical details blocks, the first usage blocks, configurations, reference, and things.
I'm sure Meta has a technical blog that you all contribute to, right?
Yes. So we have internal blogs, but it's not a condition to be shared to the public. So we need to convert them.
Okay. He's driving you. And then Rohini has one more. How do you, and then we're going to wrap, how do you determine and keep track of the staleness?
So I think like I did share like a small architecture diagram, which did talk about like we have all these pub/sub models, which keeps getting the events from the metastore. So anytime like the partition gets new events on the partitions, whether like alter or delete and things like that, we get like a request and we mark the partition stale in the metastore for the materialized view.
All right, so let's go quickly. We have about 2 minutes to cover a lot of questions. And anything we miss, let's connect in the Presto Slack, please. Devesh, thank you for pointing this out. Can you shed more light on why, I can't even actually read all of this. Can you shed more light on why outer joins are not supported, or where subqueries, does doing so destroy the one-to-one partition bookkeeping by way of the M view and base table?
Yes, I think like we want to really know. I think like some of the things I talked about in the partition mapping is that we want a witness of every partition from the base tables in the materialized view. And left outer join and right outer join, the data come from any table. So figuring out, keeping track of what's coming from where is really hard in the left outer join and right outer join. Something we want to work towards, but it was pretty hard, and we did not prioritize it at this point. But we do want to.
Cool. And then let's do one more, and then we need to wrap. Can you share which parts of the presented infrastructure around MVs will be open sourced?
So I think like pretty much everything is open source except the automatic scheduling part, which keeps ingesting new partition data into the base tables, or keep deleting it as well. So that's the only part which is not open source, but rest all is part of the open source. In fact, like if you go to the GitHub, you can search with the label materialized view. You should be able to see all the PRs and functionalities and details about it.
So you're going to meet us in Presto Slack, right, for the few questions so people can find you. Maybe not right now, but
sure. Yeah, I can be there. Yeah.
Okay. Out of respect to the people after us, let's see. So Slack, I'm typing and talking, and listen to me. So everyone's saying thank you so much, and I thank you so much. And this engagement is incredible. And Devesh, sorry we missed your question till the end. And thank you, Bogdan, and everyone who has contributed so much. And Rohit, you did a fantastic job, and I'm sure everyone is super, super excited for what we have coming in the future. What you're working on.
Thank you. Yeah, please let us know in the Slack, not just today, but anytime later as well, or any day later as well. And we'll be happy to collaborate and answer your questions.
Fantastic. Let's roll. We'll see you in the next session. Bye-bye.